Imagine compressing 800 years of scientific discovery into a single year. AI just did exactly that. In 2023, artificial intelligence predicted 2.2 million new materials, more than all of humanity had discovered throughout recorded history. Startups founded by the architects of ChatGPT and Google DeepMind reached billion-dollar valuations in months, not years. This is the story of how machines are discovering the materials that will power our future at the atomic scale. First, what exactly are materials? Materials are the fundamental substances that make up everything we build: the silicon and computer chips, the lithium and batteries, the carbon fiber and airplanes. Every technology breakthrough depends on discovering materials with exactly the right properties. For decades, materials discovery was painfully slow. Watch this timeline unfold. From initial concept in the lab to a market-ready product took 10 to 15 years. Every step required expensive experiments, trial and error, billions of dollars spent on research that went nowhere. And the result? By 2023, humanity knew of only 48,000 stable materials. That's it, after centuries of science. Meanwhile, the climate crisis demanded immediate breakthroughs: better batteries, cheaper solar cells, materials that could capture carbon from the air. But the bottleneck wasn't human creativity. It was the sheer complexity of predicting how atoms would behave when combined in new ways. Finding a new material was like finding a needle in a haystack the size of the universe. Then came November 2023. Google DeepMind and Berkeley lab unveiled GNoME, a graph neural network that could predict whether materials would be stable. Watch the network explode outward. From a trained model, 2.2 million material predictions radiated into existence. 800 years of human knowledge compressed into computational months. But here's what made it real. Berkeley's A-Lab was an autonomous robot that could actually synthesize these predictions without human intervention. In just 17 days, it created 41 new materials. The AI predicted, the robot built. Within months, 736 materials were independently verified by researchers around the world. The predictions weren't just theoretical anymore. They were real. 2024 was about proving it could scale. See how the computations multiply. Meta released OMAT24, the largest open materials dataset ever created. 118 million density functional theory calculations, each one a quantum simulation of how atoms interact at the molecular level. But this wasn't just theoretical anymore. OCX24 tested 525 catalysts in real experimental conditions, the largest catalyst screening in history. The results? 700 to 1,000 times faster than conventional methods. AI wasn't replacing chemists, it was giving them superpowers, narrowing billions of possibilities down to the most promising candidates. What used to take months now took hours. The screening bottleneck was broken. By 2025, we reached unprecedented simulation scale. Watch these atom clouds expand. USC's Allegro FM model, running on the Aurora supercomputer, simulates 4 billion atoms simultaneously. 4 billion. That's 1,000 times larger than previous methods, with quantum-level accuracy maintained throughout. We're not approximating anymore. We're simulating reality, predicting exactly how materials will behave before they're ever created. And the discoveries? Carbon-neutral concrete that captures CO2 while it cures. Materials that could transform the construction industry, the third largest source of global emissions, into a carbon sink. This wasn't incremental progress. This was exponential acceleration in computational material science. And then the market caught on. Follow this growth trajectory, from seed funding to unicorn status in a matter of months. Periodic Labs, co-founded by the architect of ChatGPT and a Google DeepMind scientist, reached a billion-dollar valuation faster than almost any deep tech company in history. Cusp AI raised a $100 million Series A advised by AI pioneers Geoffrey Hinton and Yann LeCun. This wasn't just venture capital hype. This was recognition that AI-driven materials discovery could unlock trillions in market value. Better batteries, cheaper solar panels, carbon capture materials, quantum computing components. Every major technology breakthrough depends on materials we haven't invented yet. Top talent from frontier AI labs proved they could build the next generation of industrial giants, from seed to Series B in record time. So what does this actually mean for the real world? Look at these applications radiating outward. Every field is being transformed by AI-discovered materials. Batteries. 528 new lithium-ion conductors. That's a 25-fold increase. Designs that use 70% less lithium. Graphene materials. 52,000 new variants, a 52 times increase in what we knew before. Fuel cells got 9.3 times better with AI-optimized catalysts. Not 10% better, 9 times. This isn't theory waiting in research papers. Climate solutions are being deployed. Carbon-neutral concrete, materials that remove PFAS, forever chemicals from water, compounds for direct air capture. Even quantum computing, the holy grail of computation, is being accelerated by AI-discovered superconductor candidates. Better batteries, cheaper solar, carbon capture, faster chips. The entire technology stack is being rebuilt from the atomic level up. In just 3 years, we've witnessed a complete transformation of material science. 2023 proved AI could discover materials at scale. 2.2 million predictions that changed everything. 2024 scaled to billions of simulations and real experimental validation, bridging theory to reality. 2025 brought billion-dollar valuations in months and 4 billion atom simulations. Exponential acceleration in every dimension. The market for AI materials discovery is projected to reach $11.7 billion by 2034, growing at 26% annually. We went from 48,000 known materials to over 400,000 stable candidates in less time than it used to take to discover a single new material. The materials that will power our clean energy future, revolutionize computing, and solve the climate crisis, they're being discovered right now by machines that never sleep. The next industrial revolution is happening at the atomic scale. If you found this helpful, subscribe to the channel for more deep dives into AI infrastructure and breakthrough technologies explained.